Alright, in this video we're going to be going over nth roots. And in order to better explore this, let's quickly go over square roots, because we've been working with square roots and we're familiar with that. So the square root of a equals x if the following condition is met. If you take x and you square it, and that equals the value a. So that's our general definition of what a square root is. So, for example, if we took the square root of 9, that would be 3, and that's because if you take 3 and you square it, 3 squared, that gets you the value underneath the radical sign, 9. So, what you haven't been told yet, or what you may not know, is that a square root is only one type of root. It's a square root, so we put a little 2 here, because it's the answer to the question, what number must you square to get the quantity or the value underneath the radical sign. So in this case, you would take x and you would square it. So x would be the square root of a. It is the inverse operation of squaring a value. Even though we don't write the 2 over here, it is implicitly there. We don't write the 2 because we use square roots so often that if you just see a radical sign without a 2, it means it's a square root. However, if you can have square roots, then can't you have any kind of root? So we're going to extend this definition to be the root of a, not the square root, but in this case the nth root of a equals x. If we can take a quantity x and raise it to the nth power, and that gets us the value a. So let's see what other numbers we can get from this. So let's say we wanted to take the cubed root. We started with square roots. Let's work with cubed root. What is the cubed root of the number 8? Well, the cube root of the number 8 would be 2 because if you take 2 and you cube it, you get the number 8. Let's try another one. If you can have cubed roots, can you have fourth roots? Let's take the fourth root of 81. And these become harder and harder to see intuitively. But the fourth root of 81 is actually 3. And why? Because if you take 3 and you raise it to the fourth power, that gets you 81. Before we start working with nth roots, specifically cube roots, I'd like to go over the idea of a perfect cube. Because just as knowing your perfect squares comes in handy when trying to simplify radicals, knowing your perfect cubes comes in very handy when you're working with cube roots instead of square roots. So just to refresh your memory, a perfect square is when you take an integer like 1 and you square it, and you get 1 in that case. If you take 2 and you square it, you get 4. If you take 3 and you square it, you get 9. So you get the idea. A perfect square is just an integer squared. So what do you think a perfect cube might be? Well, a perfect cube is when you take an integer and that's right, cube it. So what's 1 cubed? 1 cubed is 1. 2 cubed is 2 times 2 times 2, which is 8. 3 cubed would be 3 times 3, which is 9, times 3, which is 27. 4 cubed would be 4 times 4, which is 16, times 4 again, which is 64. And then finally 5 cubed. And 5 cubed would be 5 times 5, which is 25, times 5 again is 125. And when you're trying to simplify expressions that have cubed roots in them, knowing these comes in very handy. Alright, so now you know some common perfect cubes. You know what a cube root is. So why don't you pause the video and try to determine the cube root of 27 the cube root of 64, and the cube root of 125. Pause the video now. All right, let's go over the answers. So the cube root of 27 is going to be 3, and this is because 3 cubed equals 27. The cube root of 64 is going to be 4 because 4 cubed is 64. And then finally, the cube root of 125 is going to be 5 because when you cube 5, you get 125. So we've seen now how square roots and cube roots and fourth roots and fifth roots all work the same way. They all answer the same question. So properties that apply to one type of root would obviously apply to all of the others. So if you recall this property, the square root of a times b equals the square root of a times the square root of b can now be extended to not only the square root, but to the nth root. So this actually applies for any type of nth root. Now, the type of root has to be the same, so you can't mix up square roots with cube roots and fourth roots and fifth roots. But if they're all square roots, if they're all cubed roots, if they all have the same n, then this property applies to those radicals as well. So let's say we had the cubed root of 16. How could we apply this property to simplify this radical expression? Well, I could rewrite the cubed root of 16 as the cube root of 8 times 2. So remember, when you're trying to simplify radicals, I told you that you needed to find the product of a perfect square and then some other number. But in this case, 8 is not a perfect square, it's a perfect cube. So we can simplify the cube root of 8. The cube root of 8 we know is 2. And the cube root of 2, since 2 is not a perfect cube, that can't be simplified, so it's left as the cube root of 2. So the cube root of 16 simplified would be 2 cube root of 2, or 2 times the cube root of 2. So let's try another one, the cube root of 32. Now I did the first one. Why don't you pause the video and try this one on your own? All right, let's see how you did. So what we're looking for is to factor 32 into the product of a perfect cube and some other value. So 32 is 8 times 4. Now 8 is a perfect cubed. So the cube root of 8 times 4 equals the cube root of 8, which is 2, times the cube root of 4. And 4 is not a perfect cube, so it cannot be simplified. So our simplified expression is 2 times the cube root of 4. Now let's do one last one. Let's take the cube root of 54. All right, try this one on your own. Pause the video now. All right, let's see how you did. So, you should have factored 54 into the product of 27 and 2. And since 27 is a perfect cube, we can simplify this expression using this property. So, the cube root of 27 is 3. And then the cube root of 2 cannot be simplified, so we'll just keep that as the cube root of 2. So the cube root of 54 equals 3 times the cube root of 2. Let's take a quick minute to remind ourselves what the multiplication property of radicals says. If you have the square root of a product AB, then that'll equal the product of the square root of A times the square root of B. We use this property extensively to simplify square roots. So for example, if we had the square root of 12, we could rewrite that as the product of a perfect square and another value. So in this case, the product 4 times 3. And what we can do there is the square root of 4, the square root of 4 is 2, so we can simplify that. But the square root of 3 is an irrational number. We can't simplify that, so we leave it as the square root of 3. And that is an application of this multiplication property of radicals, where if we can split the radicand up into a product of two numbers, one of which being a perfect square, then we can simplify that part of the radical. How do we extend this definition, or how did we extend the definition of roots? We didn't disregard square roots, but we said, you know, it doesn't have to be a square root, it can be any kind of root. So we now know these as nth roots. And so in this example, if this were a square root of 12, then there'd be a little implicit 2 there, an implicit 2 there, and an implicit 2 there, signifying square roots. But since we can have any kind of root, what would happen if we took, let's say, the cubed root of 16? The cubed root of 16. Well, applying this property, if we can split 16 up, if we can factor it into the product of a perfect cube and some other value, then we can simplify this radical. So let's see if we can find such a product. All right, this is a cube root. We're looking for perfect cubes. So if I remember my perfect cubes, 1 cubed was 1, 2 cubed was 8, and 8 is a factor of 16. So I could rewrite 16 as the product of 8 and 2. Now 8 is a perfect cube. So I can take the cube root of 8 and write it as 2. That's a rational number. Now the cube root of 2 is an irrational number, so we can't simplify that anymore. So we're just going to leave that as the cube root of 2. So in the same way that we simplified square roots, we can simplify cube roots and fourth roots and fifth roots and any kind of root. So let's give you a practice problem. Let's take the cube root of 32. I want you to pause the video and see if you can use this same method to simplify the cube root of 32. So pause the video now. All right, let's see how you did. So remember, in square roots, we were looking for perfect squares. In cube roots, we're looking for perfect cubes. So I hope you saw that 32 could be factored into the product of 8 and 4. So 8 times 4. Now the cube root of 8, is 2. And the cube root of 4 is an irrational number, so we're going to leave it as just the symbol, the cube root of 4. All right, let's give you another problem. Let's see how you do on that. Let's take the cube root of 54. The cube root of 54. All right, again, you're looking for perfect cubes. All right, remember what your perfect cubes were. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and that's all you should need because you're just trying to factor 54. So obviously one of your factors needs to be less than 54. All right, so that leaves you with 3 options. All right, pause the video and see if you can simplify this now. All right, let's see how you did. So what you should have seen is 54 can be factored into the perfect cube 27 and 2. And now we can simplify the cube root of 27. That's the rational number 3. And the cube root of 2 is irrational, so we leave it as the cubed root of 2. And that's it.